Friends, welcome back to my channel. When we see ATX power supply, computer power supply, these are different types. Some of them are using TL494, KA7500, or some of them are using combo controllers. If it is using TL494, it is using an additional protection circuit that will monitor the voltage and the current. Today we will see this LM339 comparator IC, how it works in the circuit, so that when you are repairing any circuit, any power supply, it will become easy to understand and it will become easy to troubleshoot. When we know what is the circuit, how it works and what is the fault, then we can repair it very easily without any hurdle. It is a question from one of my viewers. He asked me to explain the function of this operational amplifier IC. It is using LM339 or UTC339. It is differential comparator. Comparator, basically it is type of operational amplifier. Operational amplifier have a adjustable gain, but it have a fixed gain. It will compare two pins. If these are equal, it will give some result. If these two pins are different in level, it will give another result. When we see LM339, it have 14 pins. Pin number 3, that is VCC pin. Pin 12 is ground. And if we see pinout, it have 4 comparators. Each section have 3 pins: inverting input, non-inverting input and output. The first section, pin number 6 and 7 input, pin 1 out. Second section, pin number 4 and 5 input, inverting, non-inverting. The negative sign, that is inverting input. I will make a in detail practical video with theory on comparator and operational amplifier. We will see it, but just here it will compare the voltage on these two pins and it will give decision in the output. We will see practically so that we can understand how it is working. When we see this IC here, it have 4 sections and 4 sections have 4 different jobs. The first, it will ensure that the supply is provided, standby section is working, and the green pin is grounded. If we ground manually, that is one subject. If we turn on our PC, the voltage available on this pin will ground it from the motherboard. So that is called PS on interlock. At that time, these voltage are grounded. How these voltage are generated and how it will grounded and how this circuit will work, we will see. First section. The second section, it will monitor the current. There are 2 different type of techniques. Some power supplies use current shunt resistance in the output side. That are some branded power supplies. We can say HP, Lighton, Ekbel, like that. But these cheaper power supplies and very commonly used power supplies, these take a signal from this pulse transformer, that is pulse transformer plus current transformer. It has 2 jobs. First, it will transfer the switching voltage from this PWM controller to the MOSFET, to the IGBT, to the transistor, and how much current is flowing in the primary side, it will reflect back to this comparator and the current control pin here. The third section, it will monitor the voltage, that is 5 volt. If the power supply is good, standby voltage are available, and then the power on command is available, after that it will start to generate 5 volt at red wire. When this 5 volts are exact perfect within range, it will give PG signal, power good signal, to the computer to complete its next steps. If these 5 volt are missing, immediately it will give a command to the computer to turn off the PC so that it will protect the PCs, the system, from damage. Next is voltage sense. That is to monitor all the voltage, 12 volt, minus 12 volt, 5 volt, 3.3 volt, all sections it will monitor. Let's see it practically. When our standby section starts working, it provides voltage 12 volt to 14 volt at pin number 12 of this IC, that is KF7500 RTL494. At that time it will provide 5 volt reference from its pin number 13. These 5 volt are routed to pin number 3 of this IC from here. From this point, these are reaching at pin number 3. So this IC will take fixed voltage. Why? Because it have to monitor, it have to decide. So for that purpose it needs regulated voltage, because these voltage are precisely regulated from this IC. Either the voltage are increasing here, decreasing here, respect to anything, it will regulate 5 volt. So these 5 volt are provided here. The same 5 volt are pulled up using a resistor, and these are provided to the reference pins. In first step, I will apply voltage through this series lamp. Now the power supply is on. Friends, if you don't have a good practical experience in power electronics, never try to repair. In the first step, we will check voltage at pin number 3 and the ground. Here is pin number 1, 2, 3 and ground is pin number 12. It is 4.9 volt. This time it have just only standby voltage at purple wire 5.1 volt and the green wire that is pulled up. You can see it is pulled up. So we have 5 volt here, 1, 2, 3, 5 volts, 4.965. These are regulated voltage. Now we will see the first operational amplifier, that is pin number 6. Inverting input. Check pin number 7. Pin number 7 is 2.39 volt. Here 2.39 volt at pin number 7. And check pin number 6. That is 4.9 volt. So pin number 7 is provided a reference voltage with this voltage divider network 1, 2 and this resistor. So it have 2.3 volt, pin number 7. It is power off condition. And pin number 6 is now 4.95 volt. Why? Because pin number 13 is providing voltage and these voltage are pulled up at this point. So this is PS on command. This PS on command is pulled up through this resistor. So these are resistor voltage. It is 15k resistor. When this pin is high, the pin number 1, that is output of this operational amplifier, it is 25 millivolts. So here is 25 millivolt, and with combination of all its network, the pin number 4 here will remain high. 1, 2, 3, 4. Pin number 4 or TL494 is high now. So the system is off. There is no output voltage. When we connect this pin to ground, Let me connect multimeter and then I will make jumper. Pin number 6. We can see when pin number 6 is low, pin number 7 have the same voltage 2.3 volt. At that time pin number 1 is high. When it is high, it will operate the next comparator and it will drop pin number 4 here. When this pin is down, pin number 4 is down, at that time we are taking output voltage 3.3 volt, 5 volt, 12 volt, all the voltage are in output. So we can say when inverting input is less than the non-inverting input, when it is 0 volt and it is 2.3 volt, at that time this pin will go high. When the inverting pin is low, it will compare both voltage anytime. When pin number 6 will drop from 2.3 volt, it will turn on the power supply. When pin number 6 will raise up, then pin number 7, it will turn off the system. Now I powered off again. Check pin number 5. It is 151 millivolt. Pin number 4, 1.25 volt. Here is different scenario. Pin number 4, that is inverting and it is reference pin now. 1.25 volts. This is current sense pin. How it will sense the current? It will sense the current from this center transformer, this one, the pulse transformer that is here. When the current will flow in the secondary, when the current will flow here, the part of this winding is connected here. So the primary current will pass in the winding of this power transformer, the large one, and series capacitor is here, series coupling capacitor. So it will measure the current, so its magnetic field will cause to induce voltage, and these voltage are induced here, and these are coupled to pin number 16 of TL494, and these are connected to pin number 5. When the pin number 5 of this operational amplifier, 5, 6 and 7, this pin number 5, when it is off, it is giving 151 millivolt. When it is on, just without load, it is giving 850 millivolt. 850 millivolt. When it is off, 151 millivolt. And when we will turn it on, pin number 5, that is 850 millivolt. And I will connect a 40 watt load, about 35 watt load, and I will connect to 5 volt section. Now I connected 40 watt load to 5 volt section and it is 900 millivolt. Why it is not turning off? Because our pin number 4 is 1.25 volt. That is here 1.25 volt. Anytime when pin number 5 will exceed from pin number 4, it will turn off. Because this time the inverting input is more than pin number 5. Let me connect. It is pin number 5. Now I connected 75 watt load and it is now 1 volt. Pin number 5 is increased. The problem here that it is monitoring the current. Let me connect the same 45 watt load to 12 volt section, and then we will see what is the condition at pin number 5. We can see it is now interlocked. Now the power supply is turned off. As the current will increase at that time, the output will turn off. Now we have to remove it and we have to wait until the power supply will work again. This time we have 12 volt. When it will detect some more current here, immediately it will turn off. Why it is turning off? The problem. It is monitoring the current. The same time it is monitoring the voltage from the number 4 operational amplifier comparator. That is this side. From this point it is monitoring the current, and it is also monitoring the voltage from here that are connected to pin number 11 through this summing point. 5 volt, 12 volt, minus 12 volt, minus 12 volt, all voltage sections are connected here, and if all the voltage section will increase linearly, at that time this will monitor that the voltage are raising up linearly and the current is raising equally. If there is imbalance between voltage, what will happen? The one power supply will drop, the other two will increase. So that will cause to trip this comparator. Pin number 8, that is 1.26 volt reference. Just only standby section is on. The green wire is disconnected now. Pin number 8, 1.25 volt. 1.25, it is a reference. These voltage are applied to this pin and it have to monitor the pin number 9. This time the pin number 9 is just only 66 millivolt. Turn on, it will receive 3.6 volt. When it is off, 66 millivolt. When it is off, we will check its output, pin number 14. Pin number 14 is now low. When we will turn it on, it will receive voltage at pin number 9, that is 3.6 volt. 3.6 volt will high and this pin is low, that time it will activate. And now pin number 10, that is 2.5 volt reference when the power supply is off. 10 is 2.5 volt reference. Pin number 11, 11 is 23 millivolt. When the power supply will turn on, this pin will receive 4.595 volt. That is this red voltage, red wire voltage. Passing through resistor, it will receive 5 volt here at this pin, 4.6 volt. When it will receive 4.6 volt, it will provide a PG signal, power good signal, that is 5.25 volt. That is pulled up with this red wire. When the power supply is working good, it has secondary output. At that time it will give from pin number 13 PG signal, power good signal. Now if there is any interruption in the power supply, at that time it will disconnect pin number 5. It will pull down pin number 5 to turn off the PC. When it will turn off the PC, all the system will turn off as well. Now the question, how this circuit will monitor the voltage? And it will monitor the voltage through this summing point if the all power supplies are loaded equally. At that time this pin number 11 will raise up smoothly. At that time the compensation voltage from pin number 3 of this TL494 will reach to pin number 9, and it will measure how much the voltage adjustment are required here, because it is taking compensation. When the current will increase, the current feedback is also reaching at pin number 16 of this IC. If we see this transformer. This is pulse transformer. Pulse transformer, it has central wave winding. Winding two ends are connected to these transistors 1 and 2. This 1 and this 2. These two transistors are connected here, here and here. But this winding, it is a current sense winding. How much current is flowing in the main transformer, that will pass through this transformer. So these voltage are reaching here, these are rectified here. Here we have rectifiers and current limit resistors here, and these voltage are reaching to pin number 16 of this IC, that is here. Pin number 16 of this IC through this point, and the same voltage are passed to pin number 5, that is here. That voltage are passed here. So this IC pin number 5 will receive the same current feedback. If any time the current will increase, this will turn off. So now let's check by making a bypass. Now for test purpose, for best understanding, I will connect a jumper and I will disable this pin number 4, that is dead time control, which is being controlled from this LM339. I will connect pin number 4 to ground. Now I made a jumper between pin number 4 to ground, so that if there is overcurrent condition, if there is under voltage condition, if there is over voltage condition, we will monitor. Now I will not make jumper, we will monitor the voltage. We did not turn on the power supply, but power supply is now turned on directly. 3.3 volt, it is 5.25 volt, and here we have 12.32 volt. And if we monitor this IC, 2.3 volt, still the pin number 6 is high. We did not generated a power on command from this IC, we interlocked directly. So now this IC is disabled. Now we will see the effect of the current and the voltage. Let me make it jumper so that this IC will enable. Now this IC is enabled. We will see the current detection pin, that is pin number 5. 791 millivolt without load. This time we are not connecting load. Now I will connect load. Now I will connect load to 5 volt. It is 1 volt. Still the IC is working within limit. Now we will connect two sections. We can see it is near 1.1 volt. Now if we will connect load to 12 volt section, this is pin number 5. Now it is 1.38 volt, and if we check pin number 4, that is 1.25 volt. This time the current is flowing more than its reference voltage, so it will turn off that time. So this is the protection. Similarly here, the voltage. When we connect load to 5 volt, first we will check voltage, 3.3 volt, 5.25, and here is 12.3 volt. I am connecting load to 5 volt. The 3 volt is now 3.4 volt. This is the biggest problem. When before this it was 3.3 volt. We connected a load to 5 volt section. When it is 5 volt, the 3.3 volt also increased. Why? Because we applied load to one power supply, and this IC detected that there is voltage drop. By the combination of this network, that is 5 volt, 12 volt, the summing point, if any one section will drop, this IC will adjust its voltage when it will adjust voltage to compensate this 5 volts, the other power supplies will increase automatically. Here we have load, it was 5.2 volt, this one is dropped, the other two increased. 12.35. Before it was 12.3 volt, now 0.05 volt, 50 millivolt. But this one approximately 150 millivolt increased. So this is the problem. When we put load on one power supply, the other power supplies will increase automatically. One will decrease, two will increase. So let's connect to 12 volt. Without load, 3.3 volt, 5.24, 12.3 volt. I am connecting load here. Our this power supply now 3.37, 5.32. This is increased and this one will decrease because here is load. Why? Because the summing point of three power supplies is connected together to this pin, that is pin number 1. If you will monitor just only one power supply, if you hack it, if you will convert it to 12 volt, at that time we will disconnect all other power supplies and we have to monitor just only one power supply if you want to adjust it for 12 volt. So we need to remove the protections for 12 volt, 3 volt and 5 volt, and we will adjust just only one line, that is 12 volt, which we need. Finally, as in my last video, I suggested never play with any design that is provided some manufacturer and it have all protections. If you want to remove protections, you have to understand what you are doing, as we studied here. If this power supply 4.6 volts, that is resisted voltage from this power supply, red wire, if these are missing, PG signal will miss. So if we know where is the problem, what is the exact location of the fault, then we can see. If this pin number 9 will take some more compensation voltage which are applied to pin number 3 to pin number 2 here to adjust the voltage. When this compensation will increase, it will detect that there are under voltage and there is overcurrent. When these two conditions will meet, under voltage, overcurrent, over voltage, these protections will automatically activate and it will protect the next circuit. In our upcoming session, we will see how we can increase the voltage. For that purpose, if you want to increase, as I said, never try to play with any design, but if you are willing to do it at yourself, but I will share the details how you can do it. If you can do it, at that time you can adjust all the voltage, you can remove other windings, you can adjust also. If 250 watt, you can take 250 watt from one section, from one winding. We will see it. If this video is good, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.